Okay, so good afternoon, good morning, good evening, whatever time you guys are on right now. Um, I would put together this presentation to talk about mastitis, to talk about the product line that we have at Fair Animal Health. So my name is Rodrigo Bicalho. I work at Cornell University, but I'm also the founder and the CEO of Fera Diagnostics and Biologicals. If you're listening to this presentation, it's because you are one of our clients, and I'm happy to share my knowledge of 2 decades of research in mastitis, microbiology, and we're very grateful to have you as a client. So the goal today is to review a few things. We're going to focus on the importance of identifying different pathogens and treating mastitis according with the pathogen. Also, we're going to talk a little bit about subclinical mastitis and control of contagious mastitis agents, such as Streptococcus agalactiae and such as Staphylococcus aureus. All right, so title of our presentation today is Practical Discussion on Control of Contagious and Environmental Mastitis, including the use of diagnostic tools on farm, which are developed and commercialized by Fera Diagnostics and Biologicals. And let's just start talking about mastitis in general. So mastitis is the most important disease of dairy cows. And it doesn't matter where you are in the world, if you're milking cows and you are aware of the challenges of milking cows, you will acknowledge, recognize that mastitis is indeed the #1 disease that is causing the tremendous economic losses to the dairy industry. It doesn't matter if you're in India, in the US, in Canada, in Brazil, Uruguay, it's all over the world, it's the same thing. In the US, we estimate that the disease causes about $2 billion in economic losses, which is tremendous. And if you think about it, right, so we estimate that on average, a case of mastitis costs $200 per cow per year. And that adds up to be $2 billion a year just for the American dairy industry. And this is a disease that we have been studying for centuries, scientifically studying for centuries. Have over 40,000 manuscripts published in the literature, in the scientific literature, between 1916 and 2019, and yet it remains the most relevant disease in the dairy industry. And the reason why I tell people is not that we're failing in controlling mastitis, is that mastitis is a moving target. It used to be in the US that Streptococcus agalactiae was the major pathogen causing mastitis, second only to another contagious pathogen, which is Staphylococcus aureus. Now, we were able to eradicate Streptococcus agalactiae from the country in most part. There's still sporadic cases here and there, but we just don't find Streptococcus agalactiae anymore. It's gone. And Staph aureus now, it's pretty much controlled together with Mycoplasma bovis as well. Now, the absolute eradication of Streptococcus agalactiae and the control of the other contagious pathogens like Staph aureus and Mycoplasma bovis opened up a window of opportunity for opportunistic bacteria. So when you have a mammary gland that is absolutely clean and healthy, with basically no somatic cells to defend, that mammary gland is exposed to attacks from environmental pathogens. Now, we controlled Strep agalactiae, we controlled Staph aureus, we controlled Mycoplasma bovis, but we're not controlling the environmental microbes such as E. coli, Klebsiella, Streptococcus ubris, and Streptococcus dysgalactiae. So mastitis remains a relevant problem. So if you have contagious mastitis, you should control that first. And the next step is to control your environmental mastitis. You can do both, you should do both simultaneously. Have clean cows, good milking routines, dry cow therapy, and so on. So prevention is a moving target. It depends on the pathogen. It depends on what's affecting the farm. And it's important to to acknowledge that diseases in farm animals are dynamic and multifactorial. Often the void created by prevention of some pathogens can be filled by others. All right, so we controlled Streptococcus agalactias simply by following this 5-point mastitis control plan. Very simple. Basically, we have to have milking parlors and milking machines that are well maintained. So vacuum power pumps and lines that are well maintained and provide constant vacuum. We have the lining of the milking units that have to be replaced and have to be of good quality. So you need to have pulsators that are working properly. We have milking equipment that is appropriate. And then what we need to do is we need to identify clinical cases and record them, treat them as appropriate. And we need to do pre and post dipping and disinfection. And we need to call chronic cases of mastitis. In the US, we usually treat animals 3 times. If animals don't get better, we send them to slaughter. Or we do things like drying off the affected quarter and so on. Another thing that is incredibly important, particularly for contagious pathogens, is dry cow therapy. For many years, dry cow therapy has helped us control Streptococcus agalactiae infection, along with identification, treatment, and culling of animals as well. So dry cow therapy has become very important. And today, now that we don't have the threat of Streptococcus agalactiae anymore, we are starting to consider a selective approach to dry cow therapy, where we can identify affected quarters, like quarters that have bacterial growth, and we only treat those quarters with antibiotic therapy. The other quarters that are not affected, we just simply use an internal teat sealant to seal the teat and prevent a new infection from happening during the dry period. So this is a strategy that is developing. I'm talking about clinical mastitis. We have clinical mastitis as the very tip of the iceberg. And then we have what I like to call herd microbiology, which is basically all the disease that is brewing between cows that have not manifested clinically yet. It's fantastic to talk about epidemiology of diseases now that we're in the middle of a pandemic. So people's knowledge about infectious disease is very fresh. But we need to take into account not only the clinical mastitis, which we will talk a lot today, but also what's going on underneath as well, which is brewing around the herd, which is, do we have contagious mastitis agents in the herd? Do we have Streptococcus agalactiae? Do we have Staph aureus? Do we have Mycoplasma bovis? What about our subclinical mastitis, the ones that have somatic cell counts greater than 200,000 or 250,000? How is my milking routine? Am I stimulating the cows so they can let down their milk appropriately? Are the cows, is my milking routine achieving what I need from my milking routine? I need teats that are well stimulated and cows that are producing oxytocin. I need teats that are clean, teats that are dry, and teats that are disinfected. So am I achieving these 3 things in my milking routine? And if, the major thing with environmental mastitis is, how clean are my cows? How clean is the environment? How clean is the bedding, the kind of bedding that I'm utilizing? All of this hygiene factors are going to be associated not only with environmental opportunistic mastitis infections, but also with the transmission of contagious pathogens. Our first focus here is going to be about treatment of clinical mastitis cases. All right. I like to tell people that mastitis is a symptom of an inflammation, basically. It's basically the inflammation of the mammary gland. And that symptom, just like a fever, has many different kinds of diseases associated with that symptom. If I look at a cow, a postpartum cow, and you tell me, oh, I have a cow that has a fever, well, I need to identify the disease that is causing the fever. Same thing, I have a cow that has mastitis. Well, we need to identify the disease, parentheses, the pathogen that is causing the mastitis. So we can divide pathogens here in three major groups. We have the gram-negative microbes. These are all opportunistic infections. They're environmental microbes that get into the mammary gland from the environment and cause infections. The infections are often very severe, per acute. The animals get very sick, often systemically sick with fever, dehydration, and whatnot. The majority of the cases are going to be caused by E. coli and by Klebsiella, although we do have several other gram-negative pathogens that are also important causes of mastitis. These two will account for over 90% of the gram-negative infections. And then we have the gram-positive microbes that are environmental. So we have the major ones going to be your Streptococcus, your non-Streptogalactia streptococcus. And here we're going to have Streptococcus hubris and Streptococcus dysgalactia as the majority. We also have non-aureus Staphylococcus, we have Enterococcus and Corynebacterium. And then we have a short list of our contagious pathogens, which is Streptogalactia, Staph aureus, and Mycoplasma. So before we get to the next page, let's just make one thing very clear here. If I have 100 cases of mastitis, it doesn't matter where it is. Again, it could be in China, it could be in Brazil, it could be in the US, it could be in Japan. Give me 100 cases of clinical mastitis. If I collect a milk sample from those 100 cases, on average, what am I going to find is that when I culture the milk of those 100 cases, between 1/3 to even up to 50% of those milk samples, we're not going to identify a bacterial pathogen associated with that inflammation. So they're going to be negative or culture negative. Culture negative. What does that mean? It means that the pathogen that caused that inflammation has already been cleared by the immune system of the cow. That cow that has mastitis, clinically mastitis, but no bacterial growth, that cow is a self-cured cow. She's already better. She doesn't require treatment. So that's going to be 1/3 to 50% of your cases. The remaining cases, we can say that half of them are going to be gram-positive microbes in a normal farm. If you're not dealing with the contagious pathogens anymore, these gram-positives are going to be dominated by Streptococcus, a few Enterococcus, so Streptococcus hubris and Streptococcus dysgalactia, a few cases of Enterococcus, Lactococcus, and your coagulase negative Staphylococcus, or more recently we call them the non-aureus Staphylococcus. The other half of the cases, or 1/3 of the total cases, is going to be your gram-negative environmental pathogens, dominated by, the average is going to be half of these cases are going to be caused by E. coli, the other half are going to be caused by Klebsiella. This is on average. We don't treat gram-negative mastitis pathogens with antibiotics any longer. So if you do culture in the farm, you figure out that you're going to be treating only 30% of the clinical mastitis cases. So you can save up to 70% on treatment costs if you do on-farm cultures. We're going to talk a lot about this. So this is the work, part of the PhD degree of Amy Vasquez. Amy is a veterinarian, graduated from Cornell, has a PhD from Cornell, did fantastic work while at Cornell. Her supervisor, principal investigator, is Daryl Needham, which is also in the Department of Population Medicine here. She's done terrific work, and I'm going to illustrate this work that was published in Journal of Dairy Science. So the idea was basically saying, how well does a selective therapy of clinical mastitis program compare to a blanket therapy? We went to a large dairy farm, nearly 4,000 milking cows, and clinical cases of mastitis were randomly allocated into receiving blanket therapy. In this case, they were identified as clinical mastitis, and everybody received antibiotic therapy for 5 days. This was the positive control group, or they were allocated into a selective therapy group. In the case of the selective therapy group, the clinical mastitis cow was examined, a milk sample was collected, no antibiotic therapy was completed until the results of the culture were made. So we had gram-positive microbes were mainly Streptococcus, as we'll see. They were treated with basically 2 intramammary therapies, 12 hours apart. Very simple, very cheap therapy. Animals that were affected with Staph aureus, and only a few cows were culled, removed from the herd. If the cow had a gram-negative infection or a culture-negative infection, they were not treated at all, and they were just allowed to self-cure if that was the case. In this case, we were able to drop the treatment rate from 100%, which was the blanket therapy, to about 33%, which was the selective therapy only for environmental gram-positive microbes. So what were the results of doing this? Basically, there were almost 500 mastitis cases that were treated. The blanket therapy, you had 243 cows with mastitis. All of these cows received 5 days of antibiotic therapy with an expensive broad spectrum antimicrobial. So, you know, we're talking here in nearly 1,500 tubes of antibiotics were used. The control, which is selective therapy, had 246 cows. However, of those, only 79 cows were treated with antibiotics. So it's an incredible, only 1/3 of those cows, and only 2 tubes were used. So you went from using nearly 1,500 tubes of antibiotic to using only 160 tubes of antibiotic. 10-fold reduction in antibiotic use in this case here because of the amount of antibiotic. This is the breakdown of the types of pathogens. Like I told you, you have lots of culture negatives, we had non-significant growth, we had coagulase negative staphylococcus. The vast majority are going to be your non-strep agalactiae streptococcus. These are dominated by strep hubris and strep dysgalactia. And then gram-negative organisms, which is mainly E. coli and Klebsiella. They're about the same. So these are clinical days. These are important because these are the days that the animals were expressing clinical signs. There was no difference. Actually, if you look at selective therapy, there were fewer clinical days compared to the blanket therapy. There was also no difference in milk production, and there was no difference in linear scores. This is basically the log of the somatic cell counts afterwards. Great. Now, what they almost found a statistical significant difference here was in the survivability of the cows. Now, cows that were selectively treated based on the pathogen, only 3.7% of them died within 30 days of the clinical cases. Whether the animals that were blanket treated, 5.8% of them had to be removed from the herd or died. When you look at survival over 60 days, at 9.3% versus 11%. Again, this is favoring selective therapy. This is favoring therapy based on pathogen. And obviously, the big one is the number of days that the milk has to be withheld. In this case, we call it days in the hospital. Because you're only treating 1/3 of the animal, the other animals are being kept there only temporarily until they recover from the mastitis on their own. We don't impose a milk withhold in the cows because we're not using antibiotics. Therefore, what we see here is a dramatic reduction in the amount of days that the milk needs to be discarded. You know, only 5.8 when you use pathogen-based therapy, and that goes up to 8.8, basically 9 days when you're using. So this is basically milk that you're not selling from all of these cows. It's, you know, it's costing a lot of money. So this strategic method of treatment decreased milk withholding time by 3 days, which is dramatic, with no significant differences in days to clinical cure, milk yield, linear score post-mastitis event, additional odds of culling in the 2 month following up. So greater than 65% of moderate and mild clinical mastitis cases would not have been treated with antibiotics if all cows in this trial were enrolled in a pathogen-based protocol. So tremendous amount of opportunity in saving. And I tell people that when we intervene, these interventions, they're not cost-free. Every time you do an invasive intervention, such as, introducing a mastitis tube through the teat canal into the mammary gland, if that cow is not going to benefit from that intervention, it is very likely that you will be damaging that cow. So cows that are culture negative, if you treat them 5 times with antibiotic therapy, you're going to be damaging that cow. She's already cured bacteriologically, and you're putting antibiotics in a cow that doesn't need it. Cows with E. coli infection, we already know, they don't benefit from antibiotic therapy intramammary. So if you do it, you're actually going to be damaging that cow and not helping that cow. So a lot of times we figure out that less is better and less is more. This is one of those cases. Right, so how do we implement this pathogen by pathogen? Let's review it. We implemented with we have a line of products that will help you implement this. We're going to talk about the AccuMast Plus now, because this is a product that we developed especially for the part of the world that still deal with Streptococcus agalactia. Streptococcus agalactia is a very important pathogen, and it's in countries like Brazil, Argentina, Uruguay, South Latin America in general, including Mexico. In parts of Europe, it's making a comeback. It's in Asia, pretty much. So there's a big part of the world that still deals with Streptococcus agalactia. We don't sell this product in the US, but we sell it for the rest of the world. So what do we have here? We have 4 differential media. And the way that you always going to orient yourself looking at this diagnostic kit by opening up the lid of the plate and looking at it. So there's a white media, and you're going to orient the white media up. There's a yellow media, and the yellow media is going to be downwards. All right. So if you're looking at the plate, you're going to see the sections of the plate as it is in this figure here. So on this left side media here, you're going to have your gram-negative selective media. The way it works is we build separate kinds of media so that only certain groups of bacteria will grow in those media. So in the gram-negative side of the media, if you hold up, it's going to be on the left side, only gram-negative bacteria will grow. And then the growth can be, we can distinguish the type of bacteria by looking at the color of the growth. So there's 2 technologies they're combining. One is the selectivity of the media. We use combination of salts, combination of biosalts, sodium chloride in case of some of the media, and a combination of antibiotics and chemicals to selectively grow only certain kinds of bacteria in each section. So the left one, the media one, is your gram-negative. By the way, if it grows pink in section 1, it's E. coli. If it grows blue, it's Klebsiella. Very simple. And then you have your Streptococcus section. In this case, we actually have AccuMast Plus has 2 Streptococcus sections. One in the top that is white that will grow all streps, plus Enterococcus and Lactococcus. And the one on the bottom, which is media 4, only it selects, it doesn't allow the other kinds of Streptococcus to grow. So only Streptococcus agalactia, which is blue in both sections, will grow. But Lactococcus and Enterococcus will also grow in both sections, but they're purple. So it's simple. And then your last media is going to be your Staphylococcus media. The Staphylococcus media is the one on the right side here. And if it grows pink, it's Staphylococcus aureus. And if it grows white, blue, or green, it's non-aureus Staphylococcus. We have this well illustrated in other videos. We're also going to talk a little bit about it here. All right, so this media here is the only selective media and chromogenic media that does separation of Klebsiella nicolai, the different kinds of streps, including the diagnosis of Streptococcus agalactiae, which is going to grow blue in this section, the strep section, media 2, and also going to grow blue in the media 4, in the Strep agalactiae media, and 100% accuracy in the diagnosis of Staphylococcus aureus. So this is a fantastic diagnostic product that completes the needs for any farm in the world, actually. So it is this easy. Again, I'm orienting the plate with the white media up and the yellow media down. And here I have a sample of Streptococcus agalactiae. And you can see that it grows blue on the white section, media 2, and in the yellow section, media 4. Here I have a Streptococcus hubris strain, and you can see that it grows blue on the white media, media number 2, and it doesn't grow on the yellow media. In this case, I can say, well, this is 100% guaranteed to be a Streptococcus agalactiae, and this is other kinds of Streptococcus because it's dark blue. I know it's Strep hubris. So this is the only product that can separate Streptococcus agalactiae from the other Streptococcus, which is incredibly useful if you're trying to eradicate Streptococcus agalactiae from your herd. Let's talk about treatment according to each diagnostics. Culture negative. All right, so you got your animal with mastitis, you got your clinical sample, you collected the sample in a clean form, and you went to the lab, opened your package of AccuMast Plus, took a sterile cotton swab, and you dipped that cotton swab into the milk sample and plated it in all sections. We do it again, kind of repeat the process for each section. You incubate the sample for 16 to 24 hours. You can read it as soon as 16 hours after incubation. The incubation temperature has to be at 37 degrees Celsius. In 16 hours, you can read your results. And if there is no growth, the plate is going to be clear like this one. Sometimes milk puddles are going to form some coloration, but the coloration doesn't look like colonies, right? So they're basically streaks, milk clots, coloring. So those are culture negative plates that had some coloration because you applied too much sample or because there are clots and chunks of milk that were together with the sample. So if you're plating them, it's kind of nice to take those clots and clumps out of the media. When you do it with the swab, you can take it out. Right, those are culture negative results. If it's a culture negative cow, we're basically not going to do anything for that cow. That cow needs time to resolve the inflammation in the mammary gland. There are two separate things that causes mastitis. One is the infection with the bacteria, and the other one is the immunological response to the infection. Oftentimes, the infection leads to an inflammation, and the inflammation resolves the infection. In that case, that cow fought the infection on her own without the help of antibiotics, and she got better. We actually see a lot of that with gram-negative infection, and particularly with E. coli. You have an E. coli infection, and then you have a response of the immune system. The immune system crushes the bacteria, and you have a resolution of the problem. This is pretty common. So before, we thought the culture negative could have been, are characterized by the absence of bacterial growth in a non-selective culture plates under aerobic condition. So it could be anaerobic. It could be that there's an anaerobic bacteria, not the case. It could be Mycoplasma bovis. Yes, it could be. In this case, Mycoplasma bovis requires special culturing conditions. It's very hard to culture microbe. So if you it's always a good idea to survey your cows for Mycoplasma bovis, and this is something you have to do in a referral laboratory. So you can collect samples from your clinical cases and submit it to a referral laboratory, a good one, because not all laboratories are capable of diagnosing M. bovis. It could be an unknown pathogen, could be low bacterial load, it could be no infection, but inflammation. And actually, like I told you, most cases that you see a case of culture negative mastitis, we have a resolved infection, but we still have inflammation. So most cases are due to spontaneous cure of the infection. This is a study that we did. Erica Gunda, which is a professor now in Pennsylvania, was a PhD student in my laboratory, and these were all the postdocs and graduate students that were in the lab at the time. We basically looked at the metagenomics or the microbiome of mastitis cases treated and not treated with antibiotics. And the interesting thing is, this is basically the design and the microbiome data, which is the most interesting part. But basically, we have a healthy quarter and an infected quarter. In the infected quarter, we did 5 days of ceftiofur infusions versus nothing. And we collected sample and extracted DNA. We also performed cultures, did qPCR to look at bacterial load. But, long story short, this is a very detailed study. We have a lot of information, and if you want, I can send you the scientific articles. But when we're looking at the cases of culture negative, this is mastitis, that yielded results that were culture negatives, treating or not treating with antibiotics resulted in the same clinical outcome. So as we can see here, these mammary glands, they are, and this is a different study, but basically these animals were actually challenged on time point 0. You can see that when we challenged them, within 12 hours, have a very strong response of the immune system. That response, by the time of 216 hours later, that response is still pretty pronounced. It does not normalize. That immune response, regardless of treating or not treating these animals with antibiotic therapy, by the time we reach 200 hours here, the infection, this is bacterial counts here, is pretty much resolved. However, as you can see in the previous graph, the inflammation is still there. So inflammation, when it comes to gram-negative infections, is very successful in combating the infection, but the inflammation takes time to self-resolve. This is a review summarizing, the effectiveness of doing 2 days, 5 days, and 8 days of therapy when the mastitis culture results is culture negative or no growth. You can see that treating or not treating those animals with antibiotic therapy does not change the outcome. Today we know that those cows, about 90% of them are going to get better regardless of what we do to them. They just need time. All right, so first one, what do we do for our culture negatives, our no growths? Nothing. We're going to observe those animals. And if they need supportive therapy for some reason, maybe they're culture negative, the inflammation is so severe that they're dehydrated, they're not eating, or they have a fever, we need to treat them with palliative care. But we're not going to treat them with antibiotic therapy in any ways, okay? So no treatment, simply waiting and watching to see what happens. All right, now we cultured our clinical sample and we found E. coli. Again, if we look at your AccuMast Plus plate, you're going to be holding the plate, looking at it. The white section's on the top, the yellow section's on the bottom. The left side is your gram-negative section. So if you have growth there, like we're seeing here, and the growth is of this coloration here, that's an E. coli infection. So you have your diagnosis. It's E. coli. Now, keep in mind that mixed infections are common. You can have up to 15 or 20% of cows infected with E. coli and Streptococcus ubris, for instance. If there is a mixed infection and there is a gram-positive microbe as well, then we recommend you treat the cows with antibiotic therapy, not to treat the E. coli, but to treat the gram-positive infection. But if it's a pure infection, it's only E. coli, then we do not recommend the use of intramammary antibiotic therapy. We're not going to recommend the use of intramammary antibiotic therapy. So what do we do? Well, let's look at what happens when you treat or you don't treat these E. coli cases. Basically, the cases that were not treated 5 days of ceftiofur, you had numerically higher clinical cure and numerically higher bacteriological cure. This is not statistically significant, but the bottom line here is up to 80% of these animals are going to get better by 14 days after diagnosis, regardless the use of antibiotics. So they just get better. So you're not going to do anything for them. And this, again, is recognized in review articles, and that 90%, 85 to 90% of these E. coli cases get better regardless of antibiotic therapy. So what are we going to do to those E. coli cases? Intramammary antibiotics are not recommended independently of the mastitis core. Right, so the literature is very consistent. The lack of effectiveness clearly described. Many studies shows reduction in survivability or longevity when antibiotic therapy is used. So what we're going to do, we're not going to treat these animals with intramammary antibiotics. However, so moderate and mild cases do not need any therapy. However, severe cases must be treated palliatively. So what are we going to recommend for our severe cases of E. coli? These are cows that are febrile, not eating, dehydrated, depressed. These are cows that are not doing well, all right? So these cows, we're actually going to recommend the use of systemic antibiotic therapy. There are good evidence showing that when, particularly with the use of ceftiofur, and these cows are a severity score 3, you treat them with systemic antibiotic therapy, not to treat the mammary gland, but to treat the septicemia, the infection, the systemic infection of these animals. But most importantly, more important than the systemic antibiotic therapy for the severe cases of E. coli, is the supportive therapy, palliative care. So we want to do hydration of these animals. And here we use 2 liters of hypertonic saline. This is sodium chloride solution to 7.2% intravenously. And then you're going to offer that animal free choice cold, fresh water, because she's going to be very thirsty after 2 liters of hypertonic saline. We also give calcium borogluconate. We also give dextrose 50%. And we also use an anti-inflammatory. If the animal is not pregnant, we can use dexamethasone. If the animal is pregnant, you can use meloxicam or flunixin meglumine, one of these. Okay. The goal is to decrease inflammation, but nothing other than stripping the milk of the mammary gland has to be done for that cow. Right, so another diagnosis in our gram-negative section. This is a beautiful plate here, and you can see that the dark blue colonies, these are colonies of Klebsiella, and Klebsiella pneumoniae is the most common isolate or species of Klebsiella causing mastitis. Now, Klebsiella is worse than E. coli. So Klebsiella tends to chronify, they don't get better. So E. coli, they tend to get better. You know, the mortality rate for E. coli is high, but if you can treat the cow palliatively and she can survive the infection, they tend to get better from the mastitis. Klebsiella cows, they get systemically sick. It's a very severe infection, but they don't get better. The self-cure rate is very low. So this is probably one of the worst kinds of mastitis that affects cows, is Klebsiella. I say that if you cross an E. coli and a Staph aureus, with the exception that Klebsiella is not contagious, you get the chronicity of Staph aureus and you get the per acute cases profile of E. coli. So Klebsiellas are pretty nasty. What are we going to do? Well, severe cases must be treated with systemic broad spectrum antibiotics and supportive therapy. Again, 2 liters of hypertonic, half liter of calcium borogluconate, half liter of dextrose, and anti-inflammatory as well. Now, there are some evidence from our group and also some evidence from others showing that intramammary therapy, extended intramammary therapy, 8 days of intramammary therapy with broad spectrum antibiotic therapy increases the survivability. Now, the expectation is not that you're going to cure 90% of the cases. That if you don't treat them with intramammary antibiotic therapy, you're only going to get, 35, 40% of the cases cured. And if you treat it, it will go to 60% if you're lucky. So that's a decision that each farm has to make, each veterinarian has to make. Probability of cure is relatively low, 60%. Milk production is not only impaired throughout the productive life, you don't get better. Another one that you're going to see is Pseudomonas. Pseudomonas is rarely encountered as a mastitis cause, but it could be observed in outbreaks of water contamination, particularly the water that is used in the milking parlor. If you have lots of Pseudomonas, is a microbe that likes water, so you can have outbreak type situations. In the AccuMast Plus, you're going to see Pseudomonas as the yellow coloration or white colonies. White or yellowish colonies are going to be your Pseudomonas. So it's sporadic occurrence. It can occur in cases of outbreaks where a single source of contamination is detected. Infections become chronic and do not respond to antimicrobials. Permanent dry off the chronic mastitic quarter or culling. Severe cases must be treated with systemic broad spectrum antibiotics and fluid therapy, just like we described before. Rare, but it's there. Other kinds of gram-negative pathogens, same thing. No antibiotic therapy recommended. However, if they're a grade 3, a clinical mastitis grade 3, then we want to treat them with palliative care. Now going into the treatable cases of mastitis, and these are the ones that will require antibiotic therapy. Otherwise, they don't get better. Streptococcus hubris is going to be this dark blue coloration in the white media. However, no growth at all is going to be mostly suppress the growth of bacteria on the yellow media. So this is going to be your strep hubris. Strep hubris, if you don't treat them, they don't get better. The self-cure rate is very low, maybe 25%. And if you treat them, you can achieve 80 to 85% of bacteriological cure and clinical cure. So we must treat these cases with antibiotics. Right, so if they are systemically affected, you're going to do our palliative care package. But also, in this case, we're going to do extended intramammary antibiotic therapy, 5 to 8 days of intramammary infusions of antibiotics. Systemic antibiotics are not necessary. Streptococcus agalactiae. These are beautiful diagnoses of Streptococcus agalactiae. The white media is going to have blue growth, and the yellow media is also going to have blue growth. In this case, guaranteed Streptococcus agalactiae. We're going to use intramammary antibiotic protocols for short duration. So you can pick your antibiotic. It is a gram-positive microbe. Penicillin-based antimicrobials can work. Anything that works against a gram-positive bacteria should work for this case. Chronic cases that don't get better, again, you can expect 85 to 90% cure rate, but you're going to have some chronic cases that need to be discarded. Now, important with Streptococcus agalactiae as well is to do bleach therapy. And if you have a problem with Strep agalactiae, maybe once a month or once every 2 months, you should culture all the cows in the herd. And the ones that are Streptococcus agalactiae positive, you should treat them all. This is called bleach therapy, and it has been very successful over the years. You can also culture your fresh cows. On days in milk 8 to 14, you collect a milk sample from your cows at the quarter level, or it can be a composite sample as well for the cow. And if you're positive for Strep agalactiae, then you should treat the affected quarter as well. So, if you're really serious about controlling Streptococcus agalactiae outbreak in a herd, you should culture all the clinical cases, all the subclinical cases. You should do bleach therapy. You culture the entire herd, several times a year and treat the positives. And you should culture as well your fresh cows to identify the Strep agalactiae positive cows and treat them. So the key to Streptococcus agalactiae therapy is identification, isolation, treatment, and culling or removal of the chronic animals. Other Streptococcus and this blue growth here, and usually a lighter blue and no growth on the yellow, these are going to be pretty much your Streptococcus dysgalactiae. And we're going to do intramammary antibiotic protocol of short duration as well. They have very good response. Again, 90% cure rate in 14 days. What else are you going to find in those sections? You're going to find this purple bacteria growth here, and it will grow again in the white section and the yellow section. These are your Lactococcus and or Enterococcus. These are sporadic again. You know, you're not going to find a lot, even though Lactococcus can cause outbreaks in certain cases. You shouldn't be finding a lot of these cases. But what we're going to do with them? Use of intramammary antibiotic protocols of short durations as well. Lactococcus, we have identified and worked in a few herds with outbreaks of Lactococcus. The Lactococcus that we find is mainly Lactococcus lactis. And, you know, in this particular case, it was behaving as a contagious microbes in this farm. We were able to control it with culture and treatment. Eventually it got better. But, you know, it's not the most common. So if it is behaving as a contagious microbes, we should do extended intramammary therapy for Lactococcus, 5 to 8 days of intramammary therapy. Systemic antibiotics are not necessary again. All right, now we're moving on to our last session here. What are we going to do? Here, again, our media number 3, it's between and on the right side of the plate here. If it grows white, if it grows green, if it grows blue, then it's coagulase negative staphylococci. These are environmental opportunistic staphylococcus. They're actually pretty good news. They're simple. They have very high cure rates. They do not tend to become chronic. They're easily treatable. This white coloration here, the majority of them are going to be Staphylococcus chromogenous. And if it's blue, it's Hemolyticus, but there are other kinds of non-aureus Staphylococcus as well. These are pretty benign microbes, so they are considered secondary pathogen when they're found in healthy animals. They are not associated with mastitis. When they're found in subclinical mastitis cases or clinical mastitis cases, and when they're treated with antibiotic therapy, they tend to have very high cure rates. So if you find them in subclinical cases of mastitis or clinical mastitis cases, we should treat them with antibiotic therapy. And you can use whatever antibiotic therapy of choice you have in your availability in your country. And protocols of short durations are successful. Again, intramammary therapy of short duration, make sure you use an antibiotic that is effective against Staphylococcus. Now we're talking about another bad bug here, bad microbe, which is Staph aureus. Again, your Streptococcus section, you're going to have pink growth. You can see it's very easy to distinguish. If you identify this kind of growth, it's 100% likelihood of having Staphylococcus aureus. Staph aureus, they're not simple to treat. The bacteria causes a very deep infection in the mammary gland. It causes micro abscesses to be formed. Animals may look like they have gotten better, but then they flare up again with infection. So they don't respond well to antimicrobial therapy. So what do we recommend that we should do for Staph aureus, this is our last microbe? We want to identify them and segregate them. We want to identify them and cull them, remove them from the herd. If it is a first lactation cow, what you can do is you can identify them and try to treat them. You know, up to 40% of those cases can get better. All right, if it is an older cow, the likelihood of cure is very low. It's around 30%. You may not want to try any antibiotic therapy. So segregation and culling is a good idea. All right, so these are our clinical mastitis cases. What about our herd immunity questions here? Well, there are many things that you can act upon. Like, let's talk about our contagious agents, for instance. Subclinical mastitis, you know, a lot of farms are on DHL or they send milk samples off to get their components done or to get their somatic cell counts done, and they don't do much with the data. I actually think that they should be taking a very close look at the data and making decisions based on test date data. So this is a report. I have information here, and I'm basically selecting animals with subclinical, chronic subclinical mastitis. So it's basically animals that are more than 200 days in milk, that have a linear score greater than 4.5 for the last 2 months. They're basically bad cases of clinical mastitis. Now look at those cows, and some of these cows, I'm going to decide that, well, they've been treated, like this 25-328 here was treated 4 times for clinical mastitis. She has an extremely high somatic cell count. Linear scores are 9.2 and 9.6. This animal is 200 days in milk. Even though she's pregnant, based on the value of her replacement heifer in the US, we would probably choose to sell this animal for beef instead of keeping her. So, you know, if you're looking at your test day records, you may make culling decision based on that. In other cases, we may have good cows, expensive cows, they're making a lot of milk, they're pregnant, they have been treated for mastitis in the same quarter a few times, but they're chronic. But I want to keep those cows. So what we can do for these cows is we can interrupt milking of the affected quarter. If you know that the cow is high somatic cell count, she's been treated 3 times already on the left front quarter, So you're like, well, this quarter is definitely responsible for all the somatic cell counts that are being put into the tank for that particular cow. So instead of milking that infected quarter, that inflamed quarter, what you can do is you interrupt the milking of that quarter. You dry that quarter off. And when I say drying that quarter off, we're not killing the quarter, we're literally drying it off. So we need to identify the cow, and then we identify the cow, and we don't milk that quarter anymore. So you can put a leg band to tell the milkers, don't milk this quarter anymore. And if you stop milking that quarter, within 7 to 10 days, that quarter is going to get big, and then it's going to shrink. And the blood that was going to that quarter is actually going to go to the other quarters to compensate, and the milking of the other quarters is going to increase. So you can still have high quality milk from those cows, but she's going to get better. She'll feel better. And when she gets to a dry period, you can treat those quarters as well. Dry and affected quarter. So this is what we're going to do. We identified the cows. We're going to dry the quarters off because we already tried to treat. They didn't get better. And then we're going to do a CMT test to confirm the affected quarter. It's very clear that this is the affected quarter right here. And then we're going to interrupt milking by putting a leg band and saying, you know, just bend the unit here. Don't put the unit on this quarter any longer. We're going to dry that quarter off. Now, there are some cows that have true subclinical mastitis. These are cows that have high somatic cell count, again, above 200, 250,000 somatic cell count. They've had it for a couple of months, and they were never identified with clinical mastitis. So these are cows that deserve a chance to have a diagnosis done, and perhaps even therapy. So in this case, these are cows with subclinical mastitis, good milk production, potential to be kept in the farm. The CMT, we're going to do a CMT test to identify the affected quarter, and we're going to collect a sample of that milk. So this is what we're doing. So CMT the cow, and we identify here as the right rear quarter that is affected. We're going to collect the milk sample. We're going to culture this. Now, we have another line of products that is simpler. This is basically a cheaper product that can be used to identify cows that have subclinical mastitis, or to do selective dry cow therapy even. We call this AccuTreat. This is basically a quad plate. It has 4 sections with the same media. It's all the same media. And it will basically selectively grow all the gram-positive microbes. It's not as sensitive and specific as the AccuMast and AccuMast Plus plates are, but if there's any growth here, in the case of subclinical mastitis, you treat the animal. If there's no growth, it's either a culture negative cow or a cow that has a gram-negative infection. So you don't do anything for those cows. So you can use AccuTreat or AccuMast or AccuMast Plus to diagnose that. Okay, so again, for these cows that we decide to treat, we're going to culture it using one of our products. If there's growth of a treatable microbe, then you treat it. If there's no growth or a growth of an untreatable microbe, then you make the decision accordingly. Okay, other tools that we can use. So identification of contagious pathogens like Staph aureus, Streptococcus agalactiae. Bleeds therapy for Streptococcus agalactiae. We're going to pull samples from all cows in the herd, milk culturing and treatment of the positives. Do the milk culture and treatment of the positives. Milk culturing of fresh animals. We do this between 7 days in milk and 14 days in milk to identify Staph aureus and Strep agalactiae. And sampling animal between 7 and 14 days. We have also developed so we talked about AccuMast, AccuMast Plus, and AccuTreat, which grows all the gram-positive microbes, Streptococcus, Lactococcus, Enterococcus, and everything. And now we have a new product. If you're a farm that has a problem with Streptococcus agalactiae, called AccuStrep. AccuStrep will only grow selectively in blue collar. If there is blue collar, is going to be Streptococcus agalactiae. It is basically the yellow media in the AccuMast Plus, now in a quad plate format. If it grows blue, it's Streptococcus agalactiae. If it grows purple, is Enterococcus or Lactococcus. And then the other Streptococcus are going to be inhibited. We also have a tool that is a quad plate for diagnosis of Staphylococcus aureus called AccuStaph. So you can do whole herd cultures for AccuStaph and so on. So this is also a very useful product. So what to do to control the contagious end? Streptococcus agalactiae needs to be extended intramammary antibiotic therapy, segregation in milking line, culling the chronic cases. Staph aureus, in primiparous, we can do extended intramammary antibiotic therapy. In multiparous, in chronic cases, we do culling, mycoplasma culling. And that's what we have to share with you guys. So basically, the idea here, we have a portfolio of products here that can help you control your infectious agents. You can survey your herd for Staph aureus, segregate and cull your Staph aureus positive cows. You can survey your herd for Streptococcus agalactiae. Again, the key for eradication of Streptococcus agalactiae is identification, treatment, and culling of chronics. We have that as AccuStrep. We have a perfect tool to help you with your selective therapy of clinical mastitis, which is AccuMast and AccuMast Plus. In this way, you can treat only the microbes that require treatment and ignore the culture negatives and ignore the the gram-negative cases. And these you can help your cows, you can help your herd, you can decrease costs at the same time and advance the milk quality of your herd. And if you have any questions, please contact us. We're happy to be working with you. Thank you very much.